All right. So in this section, we are going to be looking at cantilever beams, okay, and how to draw the shear force and bending moment for a cantilever beam. Please take this very serious. Thank you very much. So let's say this is our memory aid, okay. This is our memory aid, and this is what is going to be guiding us to be able to do what? Draw the shear force and bending moment diagram of this cantilever beam. Please, and a very big please. Last semester, the questions that was uh, expected or seen at the examination hall was a simply support beam. And that reminds me more that in this semester, if you don't meet a cantilever beam in the examination hall, you'll be meeting an overhand. Okay. So please take that very serious. So without beating around the bush, let's proceed. Okay. When you have a question like this and you are being asked to draw the shear force and bending moment diagram, let's say this is your question paper. First of all, what are you supposed to do as a physicist or as a building technologist? You are supposed to draw the original problem, okay, before you proceed. So in doing that, what do we do? We are supposed to write given over here, okay. So this here is going to be our given, and in the given, we say we only draw the problem again, okay, for an additional mark. And this reminds me that you can't fail strength of material because at least if you're able to put just the given, you realize that your mark is assured. Okay, all right. So after writing your given, you just have to repeat the problem. Okay, you have to repeat the problem. You have to repeat the problem. So we had a cantilever beam, something like this. Okay, okay, and it was what? It has one load at the free end. It also has one load at midspan. Okay, the load at midspan is 90 kilonewton. 90 kilonewton. And then the load at the free end was what? 135. 135 kilonewton. Good. So let's just calibrate this. This point is our A. Here was B. And then here is our C. So we can now dimension it. Okay. Okay. So we have 3 meters over here. And we also have what? 3 meters over here. You have to redraw the original problem as you're given for an additional mark in the exam hall. Okay. Please remember to do that. So after doing this, how do you write? You have to write your what? Original problem so that the examiner will see that, oh, okay, this is the problem you are trying to solve. But without putting the original problem down, you just indirectly tell the examiner that you don't normally visit lectures or you don't watch the lecture videos. All right. Due to that, you may be penalized. So let's say this is our what? Original problem. So this is our original problem. Okay. So after this, where do we move to? We have to draw our free body diagram. Okay. And that is going to come in, let me say, that is going to come in our solution. Okay. So let's come over here and come and write solution. So this is our solution. Our solution. In the solution, what did we say we are going to be doing first of all? We have to draw our what? Our free body diagram. Okay. So in a free body diagram, this is how it's going to look like. So first of all, we're going to draw a straight line like this. Okay. After the straight line, what do we do? Because this part is a fixed support, we have to put 3 reactions. Okay. So you can do it like this. 1, 2. Then the last one is a moment. Okay. So we can put that one to the side, giving us a total of what? 3. Okay. Then realize that because this end, there was no beam over here, so we won't put any reaction over there. There was no support over there, so no reaction. It's a cantilever. Okay. And here too, there was one force at us, mid-span. The force at mid-span was 90 what? 90 kilonewton. And the force at free end was 135 kilonewton. This became our 135. Okay. Kilonewton. Kilonewton. Okay. So from there, say here was B and here was C. Okay. Good. If that is the case, uh, here is going to be our what? Our vertical force at A. Okay. Then this is our moment at what? A. That is it. And here is going to be our what? Our horizontal force at A. As simple as that. So realize that our point A was somewhere here. Okay. Now let's go ahead to calibrate it. In the calibration, we said that here is 3 meters. And here was also what? 3 meters. Okay. So after doing this, you just have to calibrate it well so that at least your full map can be obtained. Okay. As simple as this. So if you are done doing a free body diagram like this, what do? You have to write at the right hand side what free, that is what you write over here, free body diagram for the examiner to know. Okay, that this is your free body diagram. This is your free body diagram. Okay, good. From here, what do? We can start taking moments. You remember I told you the other day that moment is always taken as a support. Okay, or better still, for cantilevers, you should always remember that moment is taken at what? Both ends of the beam. Okay, so you can either take moment at A or take moment at C. So in this case, what do? Let's start by taking moment. Let's start by taking moment at A. Okay. So in taking moment at A, what are we going to do? We have to be able to write that down. Okay. Good. Before we even proceed. So I'm going to be writing that. Okay. So in starting, you want to write over here, taking moment at what? A. So we are writing over here, taking moment taking moment about or at A. Okay. So if you are going to take moment at A, what does that imply? I told you from my previous lectures, in our lecture 3 and 4, I told you that if you after you always write this, you have to put down your Visa card, okay, or your ID card. Without that, you can't move. So in doing that, we have to put down our rule, and the rule we are using is that we are saying that all anti-clockwise movements are what? Positive. Okay. So that was it. And we also learned that what? The sum of all moments taken at a point Okay. In this case, our point is what? A. So we say that the sum of all moment taken at a point is 0. So if you are taking all moment at A, what is it going to be? All is going to be equal to what? 0. So from there now, we can now start taking our moment. Okay. Good. Let's move to our free body diagram. In the free body diagram, what is the first? If we are standing at A, you realize that all the points over there becomes what? 0. Okay. All forces, or any moment that you take at A is 0. So, first of all, if let's say we are going to be taking our moment at A, okay, so what is the first factor that we should consider? If we are taking moment at here, where I just use the yellow marker to denote, that is where we are taking moment at. So you put your compass over here and open to what? You open to B. So you realize that a distance of how many meters has been covered? A distance of what? 3 meters has been covered. But we said that what? Moment is equal to force times perpendicular distance. So you have to multiply the 90 times the 3. In this case, which moment is this going to take? If you follow the direction of this, you realize that this is going to take a what? This is going to take a clockwise moment. Okay. So if this is going to take a clockwise moment, how do we write? We are supposed to write what? Minus what? 90 times 3. Okay. Good. So I'm going to be writing that over here for you to see. So that is going to become what? Minus what? Into bracket. Let's put all into bracket because the negative affects both terms. So it becomes what? 90 times what? 3. Good. Then the second one, let's go and take the second one. Let's go and take this moment too. So I clean this. Our point is still the same thing. Okay. So what do we do? Now let's say we are standing over here. Okay. We are still standing at and open our next point of the compass to here. Then we follow the direction. If we follow this direction, realize that a distance of what? 3 plus 3 is what? 6. And a distance of what? 6 meters has been covered. So in that case, we are going to multiply the 135 times 6. It's also going to take a what? A clockwise moment. So it's also going to become what? Negative. So we are going to put what? Minus over there. And there's going to be minus what? 135 minus 135, okay, times what? 6. I've placed the kilonewton somewhere because at the end of the day, you can still add it to your final answer and life becomes much more easier. All right. So from there, what other thing is left? One thing you should know about this is that if you realize that from the start of your work, or everything is being negative, 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 you should know that there is going to be someone that is going to be positive. Okay, and that is the person who is going to validate your answer. But if at a point where you realize all your values are negative, my brother, you should check, you should recheck your work or cross-check for something. Okay. So our last one obviously is going to be positive. But who is that going to be? We have to investigate and look into that. We've taken the point, the moment at B. We've also come and taken that of the C. It is telling that it is left with someone somewhere. Okay. Let's come back to our, we said that what? The sum of all moments at A should be equal to 0. Okay. Good. But you realize that over here, MA it's not a force, but it is a what? It is a moment. It is already a moment. And we have to do what? Include that in the calculation. Okay. But MA over here, which moment do you think MA is taking? MA is taking an anti-clockwise moment. Okay. This MA, let me underline the MA for you to see. This MA over here, this guy over here, it is taking a what? An anti-clockwise moment based on the direction. Okay. So without talking much, we just have to come and write what? Plus what? Moment at A. It is already a moment, so we are not going to multiply it with anything. Okay. Then after that, how do we do? We can just equate everything to what? We can equate everything now to what? 0. Good. So in doing that, 90 times 3 is going to give you what? Minus 270. Okay. Minus 270. Minus 135 times 6 is going to give you what? It's going to give you 810. Okay. Plus your what? Plus your MA. At the end of the day, you still equate all of this to what? 0. Good. 270 minus 270 minus 810 is going to give you what? Negative 1080 minus what? 1080. Okay. Plus your what? MA. When you get here, the only thing you have to do is what? Group like terms, and you realize that life is going to be much more easier. Okay. So after grouping like terms, what are we going to get? Finally we're going to get our MA. Okay. Remove the negative to the other side so that MA can stand alone. Is equal to what? 1080. And because this is a moment, it is going to become kilonewton what? Meter as the what? Unit. Okay. So this is what? Kilonewton dot meter. Okay. So let's say we know our MA. Okay. So how do we do? You have to come and take moment at what? B at C. You have to come and take moment at C to also get VA. Okay. Good. So without talking much, let's come and take our moment at C. So we are going to write over here, taking moment at what? C. Taking moment about C. Good. So what's the next thing we put down? We have to put down our ID card. Okay. And the rule we are using is what? We are taking all anti-clockwise moments to be what? Positive. So this is it. And we are saying that the sum of all moments, okay, at a point should be equal to what? 0. But in this case, our point is what? C. So at the end of the day, we are going to equate all this to what? 0. Good. After putting down our rule, now we can get busy. Okay. The only thing we are left to do now is to come and take our moment. So let's say that in this time, or in this case, where I just uh, put or circled yellow is where we are going to be standing to take our moment. So if I'm standing here with my compass, I'll open over here, realize that a distance of 3 meters has been covered. But if I take the moment, you're going to realize that it's going to be a what? An anti-clockwise movement. So it's going to become positive. If you follow this direction and you rotate your compass, you realize that the compass has covered a distance of what? 3 meters, but it's going to take an anti-clockwise movement. So in this case, we're going to write what? Positive bracket open, positive. Okay. Then you open your bracket. After the bracket open, how do we write? We are going to write 135 times what? We're going to write 135. First one is going to be 90. Okay, 90 times 3. So we're going to write over here 90. Okay, 90 times what? Times 3. Good. And also, which other point? If we check over here, you can see VA. Okay, good. You can see VA. So let me quickly clean this. Because I told you that if you take moment at a point, all the forces around that point is 0. So there is even no need for me to include the 135 kilonewton. You understand me? And that is what this rule over here is saying. Anywhere you take moment at, all the forces over there are 0. Okay? Because at the end of the day, force times no distance is 0, or force times 0 is 0. So that is it. So if we are standing over here and we are going to take our moment, it means that we are going to stand at C and open the next our compass to what? VA. So if you follow the direction at which VA is taking, you realize that VA is going to be taking a what? VA is going to be taking a clockwise moment, and that is going to make it become negative. But this time, which question do we ask ourselves? Is it going to be a what? The VA has covered a distance of what? 6 meters. So in this case, it's going to be what? VA times what? 6. But because it is taking a clockwise moment, it affects it to become what? Negative. It affects it to become what? Negative. Okay. So we are going to write what? Minus what? VA minus VA, okay, times what? 6. Good. Who else? Let's go back to our free body diagram. Okay. So when we come over here, what should we look out for? We should be looking out for a next point. But you realize that we've already taken the 90, we've already taken the VA. Okay. The HA is also a force we should consider. But looking at the direction at which the H is moving, let's go to our memory aid. What does our memory aid say? It said that all forces moving to the hot right hand side, or all forces moving towards the hot east side should be hot positive. So in that case, what do? We are going to say that positive hot HA times 0. Okay. So you're going to put a positive over here, HA. Okay. It's just HA, HA. Okay. Times what? 0. From there, what else do? We just have to consider our moment. Okay. But because our moment is already a moment, we don't have to multiply it with anything. Which moment is this taking? This is taking a hot. This is already taking an anti-clockwise moment, and we already know the value for it. So we just have to denote that and let that help us move faster. Okay. So our moment is hot plus MA, because MA is an anti-clockwise hot moment. Thank you. So this become hot plus hot MA plus MA. Okay, good. At the end of the day, we can now equate all of this to what? 0. The rest is no more physics. The rest is mathematics. Okay, so we just have to punch and remove. 90 times 3 is going to give you what? 270. So 270 minus what? 6 VA. Okay, plus what? Any number times 0 is what? 0 plus our what? MA. Good. At the end of the day, all is equal to what? 0. There is something I'm supposed to do. Come down and tell the examiner that what? But MA is equal to what? 1080. But right over here, speak to him. Okay? Yes. So you write but, comma, our MA, this MA, but, comma, MA is equal to what? 1080. That is 1080 kilonewton meter. Okay. So after telling the examiner this, you can just go straight forward and then express that. Okay. So from there, what do? We just have to rewrite what we wrote initially again. But just at this time, we are going to do what? We're going to be adding, in place of MA, we are going to put the prescribed value over there. Okay, good. So how do we do next? We're going to write what? 270 minus what? 6 VA. Okay. Now, the zero, we can even omit it. Okay. Plus hot. Now, in place of the M, we're going to put hot. Then hot. Then 80. Good. We can hide the unit somewhere. Later, if you are done with our work, and we'll just let it affect it. All is equal to what? All is equal to 0. Okay. Let's group like terms. Let's group like terms. Let's let the 6VA be here and let uh, the variables uh, to or the numbers also be on their own. We realize that this minus 6VA is negative. Okay. The minus 6VA is negative. So due to that, let's rather move the minus 6VA to the right hand side so that these people can be here and maintain their signs. Okay. So we have 270 plus what? 1080 is equal to what? 6VA. So after this, how do we do? We go ahead to what? Simplify. So 270 plus 1080 is going to give us what? 1350. 1350. Okay. Is equal to what? 6VA. I remember telling you the other day, if you get to this point, don't rush to divide. Okay. Repeat this step again for an additional mark before you divide so that the examiner can see the step which you were initially before the division. Okay. Or so that this step can show what clearly. All right. So over 6VA. Okay. So because we want VA to stand alone, how do we do? We divide here by 6. We come and divide here 2 by what? 6. Good. You realize that if you get to this point, 6 is going to what? 6 is going to cancel 6. Okay. At the end of the day, what are we left with? We are left with what? VA is equal to what? 1350 all over what? All over 6. Good. If you divide this, you realize that you are going to get what? You're going to get 22. You're going to get your VA to be what? 225 kilonewton. And that's going to become 225 kilonewton. Okay, good. From here, what else do we do? We only have to just consider all our horizontal forces. Okay, if we consider all our horizontal forces. So we come over here. This horizontal force you see over here, the HA, that is what I'm talking about. This HA. This HA is what I'm talking about. Okay. So we have to consider all our horizontal forces. So we come over here, considering all horizontal forces. So you write over here. Considering all horizontal forces. Considering all horizontal forces. Okay. So after this, how do we do? You just have to put down your ID card or your Visa card, which I told you about. Then remove. Because this time it's horizontal force we are talking about. I told you something initially that if they are moving, if the forces are moving towards the what? East side, it becomes what? Positive. Okay. And because this is no more, we are not taking moment, it's the force we are taking. We are going to just say that what? Sum. The sum is still going to maintain. So sum of what? All forces. Okay. Sum of all forces at X. Okay, because you realize that this guy is moving in the X axis is equal to what? 0. As simple as that. Therefore, your HA is equal to what? 0. Therefore, your HA, our HA is equal to what? 0. Okay. 0. 0 kilonewton. From there, what do? We come to check. Okay. And the other day, I remember telling you that the check is normally about the what? It's normally about the y-axis. Okay. So we come to our what? We come to our check. Good. So in the check too, we just have to be able to remember and put down our rule. Okay. Let's go to the memory aid. That is slide 1. You realize that in our memory aid we have over here. In the memory aid we have over here, all forces that are moving upwards are positive. All forces that are moving downwards are negative. And the forces that are moving to the right-hand side are also positive. The forces that are moving towards the west side are also what? Negative. Okay. All right. So let's move to where we were and we see how to make life much more easier. So we said that what? All forces that are moving to the north should be positive. And that is what? The sum of all forces, okay, at y should be equal to what? 0. The other day, I remember telling you that the check is normally about the what? The y-axis. So if we want to consider our what? Our free body diagram. If we want to consider our the free body diagram, how many forces are moving in the y-axis we know? It's only 3. We have VA, 90 kilonewton, 90 kilonewton, and what? 135. These 3 people, they are the only people that are moving in the what? Y-axis. So VA, because VA is moving upwards, is going to be positive. 90 is moving down, it's going to be negative. 135 is also moving down, it's going to be negative. Okay. The value we had for the VA is 225 kilonewton. So in other words, it's going to be what? Positive 225 minus 90 minus what? 135. Let's go down there and write it and see how it's going to look like. Okay. Let's go and denote it down there and let's see how it's going to look like. All right. So this is where we are. And we are saying that, first of all, I can see what? VA. Okay. And the VA, because it's moving upwards, it is what? Positive. The 90 is also moving downwards, so it becomes what? Negative. Okay. Minus 90. Minus 90 what? 90 kilonewton. Okay. Minus what? 135 kilonewton. At the end of the day, you can equate all to 0. The value we had for our VA was 225 kilonewton minus what? 90 what? Kilonewton. Okay. Minus 135. Also what? Kilonewton. At the end of the day, if you punch all this on the calculator, let's all try it together. 225 minus 90 minus 135. At the end of the day, I'm getting 0. If you don't get 0, it means that there is a mistake. You have to just be able to go back and cross-check to make life much more easier for yourself. Okay. After this, because the question is saying that we should do what? The question is saying draw the shear force and bending moment diagram. It's the diagram, okay, that the question is looking for. So we are not done. We have to proceed. That means that we have to still put down our free body diagram. But in this case, we are going to what? Indicate the forces on it. Okay, this free body diagram, we have to draw it again. But in place of MA, we are going to put 1080 kilonewton meter over there. In place of VA, we are going to put what? 225 kilonewton. Very good. So let's go down there and do it and see how it's going to look like, or it's going to make life much more easier for ourselves. So this is where we are. Okay. All right. So we have to redraw our problem again. Okay. So let's say this is our free body diagram. Okay. So it had one force at free end, and that was what? 135. It also had one at what? Mid. It also has one at mid span. Mid span. And the mid span is 90 kilonewton. 90 kilonewton. Okay. Here became 135. 135 kilonewton. Please, at this junction, I will need your maximum attention, okay, to aid your understanding. Very, 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 very much. Better still, you can grab a piece of paper, a jotter, notebook, etc., so that you can be able to jot down some important points as I proceed. Okay. I want to remember you all that it's not all that a lecturer can be able to write on the board during lectures. Okay. But the ones that come out of his mouth are the vital points that you need to understand whatever you need to understand, or actually the ones that may even be coming into exams you may not know. Okay. So please, it's always good to get a piece of paper and a pen so that when lectures are ongoing, you can be able to take note of some important points as the lecture speaks or proceed. Thank you very much. So because our horizontal force, we had 0, there is no need to indicate it. Okay, so I'm not going to be indicating it. Good. So over here, we realize that our moment was what? 1080. So in this case, let me use a different pen to write that. Okay, so that at least you can appreciate what I'm also saying. So in place of MA, I'm going to put what? 1080. 1080. 1080 kilonewton. Dot what? Meter. Because it is a moment. Okay. And then the VA is going to be what? 2, 2, 5 what? Kilonewton. Good. Good. So from here, we can now get busy. Okay. So we said that this point is our hot. This is point A. So let me denote it over there. Here is point A. And also our calibrations. We have to calibrate it to the fullest. Okay. So here is 3 meters. Here is also what? 3 meters. Okay. Good. So you have to calibrate it very, very nicely. Here, in that. All right. Better still, you can write down all your questions on a piece of paper. Later, you can meet me in the DM, see me one-on-one in groups or in person, so that you can bring your questions and I'll see how best I can be able to help you. Thank you. All right. When you get to this point, the first thing you're supposed to do is count the number of points. How many points do you have over here? We have 3 good points. Okay. So it means that we are going to be taking some cuts. But the number of cuts we are going to take has a formula, and the number of cuts or number of portion is equal to what? Number of points minus 1. Okay. So if you're having 3 points over here, we subtract 1. It means that at the end of the day, we are going to be getting 2. And our answer 2 indicates that we are going to be taking what? 2 cards. Okay. We are going to be having just 2 cards. Okay. And we can either take portion AB or we can either take portion what? BC. Good. So it means that we can take our cut at what? Let's first take our cut at AB. Okay. Better still, to make life much more easier for you, let me say that what? Our portion, okay? Our portion is equal to what? The number of points. Number of what? Number of points okay, minus what? 1, okay? So that is how you're going to know the number of portions you are going to be cutting, okay? Good. So you can keep this somewhere. You will need it. You will need it, okay? All right, all right, all right, all right, all right, all right, all right. I'm going to be cleaning this real quick so that we proceed. So first of all, let's start by taking our cut at what? Portion what? AB. Okay. Okay. So let me write over here portion what? AB. So this is our portion AB. So in our portion AB, we are we want to consider the what? The left hand side. Okay. Anytime a cut is taken, you can either choose to consider the left hand side or the what? Right hand side. Okay. So let's assume this is a beam. Okay. And it is assumed that here has cracked, a shear force has occurred over here. Okay. So we can either take this left hand side or we take the right hand side to solve for it. Okay. But in this case, we want to consider always try to take the smallest one so that it can be easier for you. If you take a complex thing, you struggle. So I want to take, because I want to take the small side, that is the left hand side. I'm going to be writing over here what? Considering the what? The left hand side. Okay. So this is it. I'm going to be writing over here, considering considering the left hand side. Okay, so now you can put down the interval. Okay, when you get to this here, if here has crack, it means that you don't know the dimension for this. Okay, I didn't know. I didn't know. I think I'll comment that. What am I say? Internet just say initially, as I add finally, no, I didn't know finally, no, name the dimension. Into first of all, the then never back. Who the zero never back. Okay. Into because a zero is less, okay, or equal to x. Okay. And this is where you apply your techniques again. First, finally, now I didn't boo, you know. You've not measured it, you don't know the length of it, so you assume it to be zero. Okay. But now that you know, what do? You're going to put 3 over there. Okay, initially, how much? What was the length of the beam? Initially, it was 3. Okay, so you say that 0 is less or equal to what? X less or equal to what? 3 meters. Good. Better still, if you want to start, uh, if you want to measure from here, your first point, you realize that if you stand at a, no distance has been covered. So it's what? 0. Initially, what was the length of the beam? It was 3. So you put your 3 meters over there. Very good. From there, the portion that the shear force occurred, you have to draw that portion. Okay. You have to draw this portion that the shear force affected, and you use that to what? Calculate your beam. If you say hane buya, baby, maybe say green line where if you say hane buya, and I find say hane crack here, will say you draw left hand side. Then they are calculating internal forces now. And we will be calculating for the internal forces over there. Okay. All right. So I'm going to be drawing my diagram. Okay. My diagram for the cut. So after the cut, this is what I can see. What you can see after you take the cut, you put it down. Okay. So after taking the cut, this is what I can see. When, wherever I shear force, okay, you should know that there is an origin. Let's just say, baby, I didn't share see buffy, you know. Okay. Okay. And this is my VA, the 225 kilonewton. Okay. Then I can also bring my moment. The moment was what? 1080. I hope you remember. Okay. So uh, from here to here, let's calibrate it. From here to here, because I didn't track. Until let's just represent it by X. Okay, because it has been cut and it is not known. Represent it by X. But we don't know the actual length of it. We have to find out in our calculation. Okay. You know that here was our A. Okay. VA was what? 225. 225. Please, not the 225 you are thinking of. It is 225 kilonewton. Okay. All right. And here was 1080. 1080 kilonewton dot what? Meter. Good. So what else? What else do we do? What else do we do? We have to come and put down our rule. Okay. We have to come and put down our rule. Okay. And the rule we are going to be putting down will depend. Okay. Because we are considering the left hand side. Look at, because we are considering the left hand side. Because we are considering the left hand. So this is the meaning of this. Because we are considering the left hand side. This is the what? This is the aspect I'm going to be drawing down for my rule. Okay. Watch. I'm just going to draw this aspect over there because I'm considering the left hand side. I'm going to draw the whole of this over there. Okay. So let's go down there and see how I do this. Okay. So I'm going to draw that, and that is going to look like this. You realize that one was moving towards the south. Okay. And the one moving towards the south, remember, it's your what? Shear force, and it is denoted as V. Good. And the one moving towards the east is your what? Neutral axis. Okay. And that is going to be your M. Always that is 0. Okay. Then after that, you realize that there was a moment. Okay. There was a moment. Okay. So the moment that it was also taken over there was what? Was anti-clockwise movement. Okay. So let me just quickly label the parts and then we see how to play with them. I said this one is V because it is a shear force. This one becomes our N, neutral axis, runs through the neutral axis. And this is our M. Okay, good. This O that I've put in here is where we are going to be putting our compass. Okay, it's where we are going to be taking our origin. Very good. So from here, the main aim of this is to know the shear force values and also the what? Bending moment values. Okay, so from here we can just move quickly forward and make life much more easier for ourselves. All right, all right, all right, all right, all right. So what do we do? We come and write over here shear force what values. Okay, right over here, shear force values. Then we proceed to solve. So here become my what? Shear force value. So let's say this is my what? Shear shear force. Shear force what? Values. Okay. So if you write the shear force values, then you underline it. Then after writing the shear force values, what else do you do? That's where you're going to put down your rule again. Shear force, look at the direction where this shear force is moving. It is moving in the y-axis. So if someone is moving in the y-axis, what did we say about people that move in the y-axis? In writing their rule is that the arrow can either move top or down. Okay. So in doing that, look at how I'm going to be doing that. It is just like what I did for the check. Okay. The rule I use for the check is what I'm going to be using over here. So we say that all forces that are moving upwards are positive. Okay. And better still, the sum of all forces moving in the y-axis. Okay. Because they are moving in the y-axis is equal to what? 0. So from there, how do we do? V is moving in the y-axis, 225 is also moving in the y-axis. Who again? No one. So in that case, because 225 is moving upwards, it is what? Positive. So we write what? Plus what? 225 plus 225. Okay. So here is going to be plus what? 225. Okay. And the vein, look at the vein, it's moving downwards. So because it's moving downwards, it's going to be what? Minus. Okay. Then who else again? You realize that there is no one else over here again. So what do? We have to equate all of this to what? 0. After equating this to 0, you realize that the rest is no more physics or strength of material, but it becomes mathematics. Okay. So you have from here, we say you are on your own. Okay. So from here, you just group like terms. Okay. You can maintain 225 over here. 225. Then you shift vein to the other side so that vein can become positive. Okay. So therefore, you can say that what? Our vein is equal to what? 2, 2, 5 kilonewton. And over here, you realize that no variable is attached to it. Because no variable is attached to it, we can denote this and call this our what? We can call it a constant. Okay, it's constant. So this can become what? This becomes our what? Constant. Because there is no x attached to it. Constant. If there was a variable, like if there was x attached to it, let's say 225 x kilonewton, it should have been a linear variation. Okay. So in this case, because there is no variable attached to it, it becomes a constant variation. Okay, it becomes a constant. Good. So from here, how do we do? We're going to talk about our interval we place over here. We're going to talk about as x is equal to 0, and we're also going to talk about at x is equal to 3. Let's see how we are going to do that over here. Okay, so from there, we're going to be saying that at x is equal to at what? At x is equal to what? 0. And I'm picking that from the interval. Look, from this interval, we say x is 0 and what? X is 3. Okay. X is less or equal to 0. X is less or equal to 3. So you have to work for that. That is why I wrote that over there. So that is going to become at x is equal to 0, comma, your shear force at A. Okay. That means VA. If you say VA, V somewhere is shear force, but V substitute A means shear force at A. And your shear force at A is going to be what? 2, 2, 5, or kilonewton. Also, at X, I'm picking that from the interval, okay? Because I already picked at X is equal to 0 already. And in this case, at X is equal to what? 3 meters, comma, your V what? First one, you say I took the A, this A, and I took what? These two people, okay? In this case, I'm going to be taking what? B. I'm going to be taking the B, okay? This B, and these two people too, okay? At X is equal to 3 meters. Shear force at B is equal to what? Blah, blah, blah. Okay. If there was a variable over there like X or something, I would have put a 3 inside and we substitute to find for that. But because this is a constant, you realize that the answer is still going to be the same. Okay. So in this case, VB, okay, VB becomes is equal to what? Also 225. That's why it becomes constant for all. So when you see constant somewhere, don't stress yourself much. Okay. It's only when it becomes linear, parabolic, ECT, etc. That is when you have to think much. All right. So from there, we are done with our shear force values. Okay. So what do we come to? We are going to do the bending moment value for this. I told you the last time we met that anywhere shear force occurs, bending moments also take place. Because right now, Cecilia say, oh, baby, now say, baby, bua. I didn't bua and bending. Yes, a bit bending, a bit tough. That is where the bending moment is taking place. Okay. So put the right over where somewhere just now that anywhere shear force occurs, a bending moment also what takes place. So once we are done with the shear force, what do? We have to come and write what? Bending moment values and also calculate for that. Okay. So this becomes my bending moment values. Bending moment values. Bending moment values. So in this case, because we are talking about bending, which rule are we going to use? The rule we are going to be using is what? Just the initial rules we were using when we're taking the moment. Look at this time, it's moments we are talking about. Okay. So because the rule we are using is all anti-clockwise movement should be what? Positive. I'm going to draw that anti-clockwise movement over here. Okay. And we say it's positive. But this case, this time, because we are going to be taking our moment at this origin, which is O, it means that at this origin, which is O, it means that, let me say, we are going to be denoting O, okay, for our various calculations. Okay, so this is now going to become what? At O, sum of all moments at O. Okay, sum of all moments at O. So this becomes what? Sum of moments at O. Sum of all moments at O should be equal to what? Should be equal to 0. Sum of all moments at O should be equal to 0. Okay, good. So from here, we can now start taking our moment. Okay, good. Let's say that when we take our compass, we are standing at what? Let's say that we are standing over here with our, okay, good. If you open to here, a distance of what? X has been covered. So if a distance of X has been covered, what can you see? You realize that the 225 is going to multiply the what? The X. Okay, then we also have a different moment, which is what? This guy is already a moment, so we'll just write it 1080, and it is anti-clockwise, so it's positive. Okay. Then which other moment do we have? We have M over here. So let's do that together and let's see the wonders in it. So we realize that the first moment you are going to take is, it will be negative. It's going to be clockwise. It's going to be what? 2, 2, 5 times X. Okay. 225 times X, because if you stand over here and you open your compass, okay, you open your compass to here and you follow this direction, it's going to take a what? This is going to take, let me say, a clockwise moment. And we say all clockwise moments are what? Negative. So that is why I put a negative over here. Good. We are done taking this moment. That 225 is going to multiply X. That is why I've written that over there. So from here, what else can we see? You don't have any other force to take moment with, but rather the rest are moment. This guy over here is already a moment. This guy over here is already a moment. So what do? We just have to consider him. But the moment is anti-clockwise, so it's going to be positive. Okay, good. So this becomes plus what? 1080. Let's move back. Who else again can we talk about? The next person we can be able to talk about over here is the M. The M, this M over here. Okay, he is the next person that we can be able to talk about. This guy over here. Okay, because it is also a moment. We've spoken about this guy. We took moments with this guy, but this guy is already a moment. Okay, we've already spoken about him, so we have to come and consider this one too. Okay, good. So in doing that, you realize that this is going what? Anti-clockwise too. So plus another what? Plus another n. Okay, plus another n. Plus another n. So plus n. Okay, good. At the end of the day, we equate all to what? So the rest is no more physics. The rest becomes mathematics. Okay. Minus 225 times x is going to give you what? Negative 225 x. Okay, good. Plus what? 1080 plus our what? And let's say all is equal to what? 0. From here, what do? We only have to group like terms to make life much more easier for ourselves. We can maintain m over here and move the rest to the what? Right-hand side. So our moment is equal to, if we move minus 225, so it's going to be positive. So it's going to be what? 225x. The rule says that once you cross the equal to sign, you become what? Your sign will automatically change. And that is why it has changed from negative to positive. Okay. The 1080, if it's crossed the equal to sign, it's going to become negative because initially it was positive. Please, last semester questions was a simply support. This semester, I have a revelation. Okay. So I'll urge each and every one of you to learn cantilever and overhanging beams very well. Thank you very much. It's just a simple advice. All right. So at the end of the day, we are done. We can't continue again because of this variable that we have seen over here. Okay. And the presence of this variable makes this a linear variation. Remember the first time I was talking about constant variation somewhere, and some people were asking questions, typing messages. But over here, the truth of the matter is that there was no variable. That's why I said constant. But in here, because there is a variable, I can denote this as what? I can denote this as a what? A linear variation. Better still, better still, because this is a moment. As a physicist, if you want to let the examiner know that you really know what you are about, you can just put all of this into brackets and add a unit over here, because this is a moment, it should be a what? Kilonewton what? Meter. All right. All right. Then, better still, after this, what must you do? You just have to tell the examiner that this is a what? This is linear. Okay. This is a linear variation to make life much more easier. Okay. So we said this was what? Linear. This becomes our linear what? Linear variation. Good. So what else do? We only come and do at x is equal to this, at x is equal to that. Then from there, we can just proceed. Okay. From there, we could proceed and make life much more easier for ourselves. I'll be showing you some trick. Don't worry about that. So from there, what do we do next? We only come in, right? At Let me just change a different color pen, okay, to aid your understanding. So I say that at x is equal to what? At x is equal to 0, comma, this time it's no more MA. It's no more VA. It becomes MA. Okay, it's no more VA, but it rather becomes MA. So moment at A is equal to what? Put all of this down. Let's say 2, 2, 5. What? X minus what? 10, 80. Okay, after putting this down, what do you do? Now you can come and write it again and put down your variables in it. Okay. So realize that our MA, which is moment at A, is equal to what? 225. 225. In place of the x, we can put 0 inside because they say at x is equal to 0. Good. 1080. If you point this, all of this on a calculator, it should give you the answer straightforward. Don't waste much time over here. Okay? Because the main aim of the question is for you to draw the diagram. And because you don't have much time on your side, you have to work with speed, but you also have to be accurate. You have to work with speed, but you will also have to be very, 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 very much what? Accurate. So you realize that at the end of the day, your answer is going to be what? If you point this in the calculator, you're going to get what? Minus what? 1080. And the unit is what? Kilonewton meter. So it becomes what? Your kilonewton meter. Good. From here, what do we do next? Someone said we have to go and take moment at what? Someone said we also have to do at x is equal to what? 3 meters. Very good. So it means that we're going to also do at x is equal to what? 3 meters. We repeat the same thing again. Okay. This time it is no more MA again. It becomes MB. You understand? Because we are talking about what portion A, B. So if we talk about A, we have to come and talk about B too. Understand? Understand. So we get MB is equal to what? 2, 2, 5, what? X minus what? 10, 50. Okay. Let's come and put at X is equal to 3 meters in. Let's put the 3 meters in it and see what we will be getting. So this becomes a 225. Now we put 3 inside over here, showing that this is 3 meters minus what? 1080. Let's all point this on a calculator and let's see what we'll get. Okay. Finally, you realize that what? Your MB, or let me say, moment at B. If you input this on the calculator, you're going to be getting minus 405 kilonewton meter. Okay. This becomes negative what? 405. Okay. The unit, you have to add a unit. An answer without a unit is considered cos 90. All right. So this becomes kilonewton dot what? Meter. The presence of the dots indicates a multiplication sign. Okay. So this is our answer for this. This is also our answer for this. Where is the shear force? This was our answer for this. This was also our answer for this. All right. So we are done with portion what? AB. Okay. Let's go and do portion. Also, let's go and take a cut at BC. And then we see how we can be able to play with it to make life much more easier for ourselves. Okay. To make life much more easier for ourselves. All right. So in this time, in this case, we're going to be taking our cut at this aspect, or we assume that the shear force occurred over here. See, I would advise you to always try and make life much more easier for yourself. If you take the cut, you can either choose to consider the left-hand side or the right-hand side. Okay. Someone will choose to consider the left-hand side, and at the end of the day, you find problem for yourself because it becomes complex. Okay. But if you take this cut, try to use the smallest part so that calculations can be easier for you. You can finish quick and move. Okay. So I will be considering the smallest part, which is the right-hand side. And you realize that life is going to be easy for me. I can move. Better still, you can still consider the left-hand side also again. And you realize that you're going to move very quick. Because I have taught you the left-hand side in this section, let's also go and talk about the hot right-hand side. And let's see how life is going to be much more easier with that aspect too. Good. So because this time I'm going to be taking the right-hand side. Look at something. Oh. If you take a clear look at the beam, they were calibrating from what? A, B, C. Understand me? But because in this case, I have taken a cut. Because in this case, I have taken a cut. Okay. And now I'm going to be doing I can't take my readings from where the cut has. Okay. I have to start from a known point. And the known point is what? It's C. So in this case, I'm not going to write portion BC, but I'm going to write portion what? CB. All right. So this becomes my portion what? Portion BC. It is going to become portion is going to become portion what? It's going to become portion CB. Okay, because I'm reading from the right to the left. I'm not reading from left to right. Thank you. So from this, how do we do? I pull down my initials, okay? And the initial we do is what? Considering the what? Right hand side. Very good. Let me quickly take this off and rewrite it well so that life can be much more easier. So this is our portion. Portion. B. Someone is confused and saying, why am I not writing BC instead of C, instead of CD? All right, let's dive in, and then with that or with time, I will explain to you the reason why I'm writing CB, but not BC. Okay, so we write considering the right hand side. Okay, so considering considering the right hand side. Good. So as usual, if I'm reading from the right hand side, initially from C, you realize that it's 0 because it is assumed that the dimension of that part is not known. Okay, just as we did for the first one over here. So you said that what? 0 is what? Less or equal to what? X. Okay, less or equal to what? 3 meters. Good. So from here, what else do we do? We are almost done. Okay, we are almost done. So because the cut was taken at this aspect, because the cut was taken over here, we just have to draw this aspect. Okay, we only have to draw this aspect, and the drawing of that is going to, how is it going to look like? Let's all go and do that together. So that is going to be, that's going to look like this. Okay, you realize the point load was here, the point load was down there. So the point load was 135 kilonewton. And it is assumed that the shear force occurred somewhere here. Okay. After you draw this, you have to remember and denote your hot origin. Then from there, what do we do? Here also becomes unknown because the thing has cracked. And if it is as cracked, you don't know the actual dimension of it. Okay. So that is why we are putting X over there. All right. So that is the calibration. Let me calibrate this side too. From here, what is the next thing we are supposed to do? What is the next thing we are supposed to do? The next thing we are supposed to do is that we are only supposed to come and put, we're only supposed to come and put, let's move to 1. So you see that the first time we took the left hand side. Okay. So that is why I circle this aspect like this for you to see. But in this time, we're going to take the right hand side. So we are going to be taking the right hand side. I'm going to clean this and show you where we are going to focus on. Okay, we're going to be drawing this over there. Just this aspect alone over there. All of this over there. Okay, to show that these are the rules we are going to be using. We are going to be playing with. Okay, good. So let's move to slide 8 and make life much more easier. So over here, which rule are we going to be drawing? But even before that, initially over here, all right, all right. So we can put down, let's put down our, let's, let's kindly put down our rules we are going to be using. Okay, let's quickly put down the rules we are going to be using. So this is the rule. The first one is going to be moving upwards to the north. Okay. This guy is also going to be moving to the west side. Then the last but not the least is the what? Is the movement. You realize that this movement is also a clockwise movement. Okay. So we just label the parts. Then you say that the one moving in the y-axis is our shear force V. The one moving in our x-axis is our neutral axis. And then this guy becomes our moment. Okay. So from here, what else are we left with to do? All right. We are going to be standing at this part. Okay, the O, where you see the aspirating the O, that becomes our origin. That is going to become our origin because that is where we are going to be standing to take our moments. Okay. So without talking much or beating around the bush, we say that first of all, let's calculate our shear force values. Okay. So let me write over here shear force values. So the shear force values. Okay. So shear force values. Then after the shear force value, what do? You say shear force are values that are actually moves in the what? Y-axis. Okay. So if they are moving in the y-axis, what do? We just have to put their rule down and accelerate. So the rule, the ones moving in the y-axis, all forces that are moving upwards should be positive. Okay. And that becomes the what? Sum of all forces at y should be equal to what? 0. Good. From there, what do we do next? Should be equal to 0. Think equal to 0. All right. So we can accelerate now. So from here, what do we do? From here, what do we do? You realize that V is moving in y-axis, 135 is also moving in y-axis. The V is moving upward, so it's positive. So you say that what? Positive V. Okay. And then the 135 is moving downwards. So it's become negative minus what? 135 kilonewton. Minus 135. Okay. 135 kilonewton. And at the end of the day, what are you going to get? Because there is no other body to consider moving in the y-axis, you can just accelerate. Okay. All is equal to what? 0. If you want to group like 10, you're going to realize that therefore your V is equal to what? 1, 3, 5, what? Kilonewton. And what is this going to become? This is just simply also going to become a constant variation. Okay. And it is as a result of what? The presence of no variable. Okay, so I write over here, this is our linear variation, constant variation. Okay, so this is our constant because it has no variable. So this is constant. So from here, what do we see? From here, the next thing I'm just going to be talking about is that what at x is equal to this, at x is equal to that. Thank you. So from here, we are going to say that what at x is equal to 0, at x is equal to 0, comma, vertical force at what? Let's come and look over here. Which portion are we considering? We are considering portion what? We are considering portion what? CB. Okay, so we talk about C first because C came before B. So we say that what? Our vertical force at C, vertical force at C is equal to what? 135 kilonewton. Okay, then from there, what else do we do? We also come and talk about the vertical force at what? Or the shear force at what? B. So we also say that at x is equal to what? 3 meters, comma, our shear force at B is equal to what? 135 kilonewton. It's nice as that. Okay, so this is one answer we had. This is one answer we had. This one's are what we're going to be using to plot the graph. Okay, so it's left with our last one. I told you anywhere there is a shear force, there is a bending moment. Okay, so if we are done calculating for our shear force value, let's go and also calculate for our bending moment value. Then we could just wrap up. Okay, all right. So we come over here and I write what? Bending moment values. So this becomes my bending moment values. Last time I saw some work some people did for me to cross-check for them. Some are writing bending moment value. It's not a value, it is values. Bending moment values. Okay. So after you just put down your rule as we were doing initially. Okay. And the rule we have always been using is what? Positive. That is sum of all anti-clockwise movement. Okay. All anti-clockwise movement should be considered positive. And we say that sum of all moments. Because this time then we are taking our moments at O. So we say that sum of all moments at O or the origin should be equal to what? 0. Sum of all moments at the origin should always be equal to what? 0. From there, what is the next thing we're going to be doing? It means that we have to start taking our moments. Okay, let's move to our diagram. This is the diagram I do for portion C after what? Taking the cut. So when I took the cut, this is what happened. Okay, if you stand over here and you take a moment, let's say you're standing at this O over here, this O junction over here, this origin, and you open your compass to here, right? A distance of what? 135 has been covered. A distance of X has been covered. Okay, a distance of X has been covered. You stand over, a distance of X has been covered. When you follow the direction of this arrow and you take your moment, this is going to, which kind of moment is this going to take? It's going to take a clockwise moment, so it's going to be negative. Okay, so it's going to be minus 135 times x. Okay, and the moment over here, which direction is it moving? It is moving, also moving in a what? A clockwise direction. So it's definitely and obviously going to also be negative. So let's all write that together. So I'm going to get minus bracket open 135 times what? X bracket close. Okay, minus what? The moment. Oh, is equal to what? 0. The M I've written, someone is asking me where it came from. It came from this. The M I wrote, it came from this. It came from this. This M you are seeing over here. This M you are seeing over here is what I just wrote over there as what? Minus N, because it is taking a what? Because it is taking this, the direction of this is taking a what? A clockwise movement. Thank you. So let's quickly proceed and wrap up. Okay. So this from here, the rest is no more physics or strength of material, but it becomes mathematics. So here is going to give you s minus 135x minus 135x. Okay, minus our n is equal to what? 0. From here, how do we do? Let's group like terms. If I were to be you, I will maintain this zero over here and send m to the right hand side. So let's do that. We're going to get 135x. Okay. If m cross the equal to sign, it becomes positive. It's equal to n. Therefore, we say if v is equal to a, then it also means that a is equal to v. Applying that knowledge over here is going to imply that, therefore, our what? M is equal to what? 1, or let me say minus 135 minus 135x minus 135x. Okay. A good physicist will put all of this into brackets and write what? The unit, so that we see kilonewton what? Meter. Better still, what is this going to become? This is also going to become a linear variation. Okay, this is going to become a linear due to the presence of this x over here. So this is also going to become a linear variation. So let's say this is also going to become a linear variation. It's also going to become a linear variation. Good. So we are almost done. From here, what do? We come and do at x is equal to this, at x is equal to that. Okay, let me quickly change the color of my marker, then we proceed with that. So we come to what? At x is equal to what? 0, comma. Our moment at what? C is equal to what? First of all, let's repeat the whole thing. 135 what? 135x minus 135x minus 135. Okay, minus 135 x. Okay, so that this was in what? All of this we say it should be what? Kilonewton dot meter, because this is a moment. That's why you can see that the unit of this is different. Okay. So from here, what do? We're going to just multiply the what? Minus 1 30 what? 5. But x is what? 0. So we put that 0 over there. At the end of the day, what do you think is going to be our final answer? Our final answer is going to be what? 0. 0. Okay. So at the end of the day, this, if this is also in kilonewton, then you realize that at the end of the day, our answer is going to be what? 0, just 0 kilonewton. Okay. So we're going to get what? 0 kilonewton meter. 0 kilonewton what? Meter. 0 kilonewton dot meter. So we are done with this. We are done with this one. So let's do for the other one too. We are going to do for MB. Okay, good. So also at x is equal to what? 3 meters. This 3 meters, this one I'm taking the 3 meters from. This 3 meters. I've done for this, I've done for that already. CB. So that's what I did for C first. Now I'm now doing for B. Good. So at x is equal to what? 3 meters. What is going to happen? My moment at what? Moment at B is equal to what? Minus 1, 3, 5 x. Here was what? Kilonewton per meter. So here is going to become what? Finally, let's put our MB in it. Let's put our 3 meters in it. Okay. So we are going to get minus 135. What is the value of x? It's 3. Okay. So bracket open. I put a 3 inside. Punch all of this on a calculator, and life is going to become much more easier for you. I would just advise you that if you're in the examination hall, even if it's 1 plus 1, please use the calculator. Even if it's 2 plus 2, use the calculator. Because in the exam hall, there is so much tension that is going to be on you. If you don't take time, 1 plus 1 in real life that you know that is 2. Because you are in the examination when there is tension on you, you can go and write 3. Okay. So I always advise that if you're in the examination or no matter the case, even 1 times 1, even if you know, try to use the calculator to confirm. Okay. And when you enter the exam hall, the first thing you should do is you are supposed to reset your calculator to the factory setting. Okay. So that you can work with a standard calculator that is going to make all your answers to be precise, accurate. Okay. But if your calculator is in a different mode and you are using it to work, it's going to be giving you wrong answers throughout. Okay. To do that, you are just supposed to press shift. If you press shift, you press what? 9. Then you press 3 equal to AC. Let's do that again. You pick your calculator and you press shift 9, input 3, input equal to, and press AC. Your calculator is back to what? Factory setting, and then you can work with it. Thank you. So after punching it, you're going to get minus 405 kilonewton meter.